Hey man, what's going on?
Nothing much, just follow the balloon and wind up in your kitchen. What are you up to?
Just cooking some eggs. Want some?
Whoa, heck yeah I do. Thanks, man.
Anytime. Just let me pull out some more eggs and...
Whoa, what was that?
I dropped some eggs.
Wow, man, really? Way to go.
Hey man, it wasn't my fault, it was gravity's.
You mean the attractive force between all masses in the universe? How do you, figure that, bro?
Well, it has to do with these quantum particles doing some loops.
Hold up, man. I thought we were talking about your basic 1 over r squared attractive monopole force, first successfully postulated by Newton back in 1687, and then proven to be 9.8 meters per second squared by Henry Cavendish in 1798.
Man, I'm talking about gravity and how it works on the quantum scale, more specifically, quantum loop theory.
So what does this have to do with my eggs?
Everything, just hear me out. So quantum gravity, or quantum loop gravity, is a theory of gravity on the quantum level. LQG, as it's known, takes the viewpoint of general relativity, a classical theory with quantum mechanics. The theory defines gravity as a property of space that comes in chunks, or that space itself is discrete, like photons. Space is woven in finite number of loops called spin networks, which make spin foams.
And why is this important for eggs and myself and the rest of the universe?
Well, it connects quantum theory with general relativity for a theory of everything. The entire physical laws, nature can be solved.
So, does this have anything to do with, spin networks and junk?
Glad you asked. Spin networks are grains of chunks of space connected by nodes. Nodes are where loops intersect. The nodes are quantum numbers with half or full integer spins. Loops are space itself due to quantum excitations of gravitational fields. Loops are 10 to the negative 35 meters, or Planck's length, in size.
Oh my goodness, that's small. I had no idea. So what's this mean for our understanding of space and what it actually is?
LQG tells us that space has an atomic structure and they are discrete and finite. Loops are wave functions of geometrics that obey on Euler-Thurwitz equations, like how Schrödinger wave function predicts the probability of a particle's position.
So what's all this mean for the subatomic universe in terms of energy, space, and time?
Space is not infinitely divisible and has a set length. For low energy approximations, they appear as gravitons. That theory also tells us that time takes place in discrete intervals.
This is starting to sound like Yang-Mills field theory. Is this related at all?
Actually, yes. LQG does have to do with Yang-Mills theory. It tells us that elementary quantum excitations of a gravitational field in terms of loops. This corresponds to Faraday's field lines of force with electrical fields.
Oh, golly gee. I bet there is all kinds of crazy math behind that, since we can't really observe it and all.
Yes, nodes of spin networks represent elementary grains of space, and their volume is measured in Planck's volume, which is h bar times the gravitational constant over c cubed. All that cubed, the square root cubed. And the elementary surfaces of spin foam's faces is 16 pi times Planck's volume to the 2/3 times the square root of j times j plus 1.
Whoa, hold up. Did you say spin foam? Is that really your thing, or did you make it up like that time you said you were making eggs?
Spin foams are formed by faces linking space networks. The faces meet at vertices. The interactions between grains of space is between these history of spin networks. Faces are histories of lengths of the spin network, and lines are edges of histories of nodes.
So, if all this really holds true, what else can we expect to find as a result of these quantum gravity loop things?
Well, LQG derives the entropy of a black hole, which equals the area of the black hole times Boltzmann constant times all that divided by 4 times h bar times the gravitational constant. It also gets rid of the Big Bang singularity idea and the inflationary expansion of the universe.
So, if all this is really true and so well supported, why isn't it considered a law and just a theory?
Well, the biggest problem is that quantum gravity is so small we can't experimentally measure it. It also violates the Lorentz invariance because LQG predicts the possibility that light can travel at different speeds with different wavelengths. We also can't find a way to compute scattering amplitudes, and the Wheeler-DeWitt equation exists in several varieties.
So, if you know so much about this gravity loop stuff, do you happen to know anything about, I don't know, making fried eggs?
Oh yeah, oh wait a minute.
And then,
Hey man, what's going on?
nothing much, just follow the balloon and wind up in your